So just let's recap of whatever we have done. Let's recap. We have x to the power of m into x to the power of n, same base. So I just need to add the power. Whenever we have a negative term raised to the power of an even number, we have the answer to be a to the power of even. Whenever we have negative term raised to the power of odd, we have negative 1 into a to the power of odd. Right? So this is what we learned till now. The next formula is x to the power of m divided by x to the power of n. So before I tell the answer, I would like to explain it with an example. So what we are looking at is a to the power of 4 in the numerator and a to the power of 3 in the denominator. So if I had to write it in the expanded form, I'll be writing it as a into a into a into a, that is your numerator, divided by a into a into a, that's your denominator. Now basically multiplication and division, in that if I get a number divided by the same number, what do you get? The answer is 1. Here too the answer is 1, here too the answer is 1, and I get a to the power of what? Individual a is e to the power of 1. So basically the answer for this is a to the power of 1. So a number which is in numerator, a number which is in denominator will give us 1 over here. So what kind of operation is happening? Is it positive? Is it addition, subtraction, multiplication, division? What is happening over here? And it's subtraction. So basically x to the power of m divided by x to the power of n is x to the power of m numerator value minus the denominator value. Right? Okay, we have a lot of questions from which we will understand this better. So we have a case. This is a general case, no complicated version. So 143, same base. Always see the base first. Base is same, but it's getting divided. So all I have to do here is 143 divided by 143, 40, 30 is equal to 143, 40 minus 30. So this is nothing but 143 to the power of 10. That's all. Make sense? Now the next question, what we're looking at is the base to be same. So they are same, but here it's division. So this will be 2a to the power of 6 by 2a to the power of 3 is equal to 2a whole to the power of 6 minus 3. Numerator minus the denominator. So this is nothing but 2a whole to the power of 3. That's your answer. The next question is case when we have negative power. A small variation. It's not too difficult if you think about it. So let's see, are the bases same? Yes, the base is same. Now I'm looking at 16 to the power of 4 divided by 16 to the power of negative 4. So this will be 16 to the power of 4 minus of negative 4. So 16 to the power of 4 minus of minus is plus 4, right? And we have answer to be 16 to the power of 8. Make sense? All I'm doing is negative of negative because the base power was negative. That's it. It's not that difficult, right? Again, is the base same? Yes, the base is same. Then we are looking at the number 143 divided by 143, negative 4, negative 6. So 143, negative 4, negative of negative 6. You can do a calculation on the sides. So negative 4, negative of negative is positive 6. So different sign, we need to subtract 6 minus 4, that is 2. So this is 143 whole square. Are the bases same? Yes, the base is what? What is the base over here? Negative 3b. Everyone please try, pause it and try. So as per our identity, all I have to do is negative 3b whole to the power of negative positive 4, negative of negative 7. So what you can do is open a bracket, 4, negative of negative 7. You can solve it separately. Negative into negative is positive 7 and the sum is 13. So that you can in turn substitute negative 3b whole to the power of 13. The next question is, I hope all of you guys have tried this and you have an answer in your mind and on the paper as well. So we're looking at base to be same and one of that is, both of that is negative 6. So negative 6 to the power of negative 10, negative 6 to the power of negative 10. Actually, you need not do this. It's the same thing. We can just cancel and write it as 1. But I'll show you the exponent way. Negative 6, negative 10 minus of negative 10. So what we're looking at is negative 10, negative of negative 10, negative 10, negative into negative is positive 10. So this is nothing but 0, is it not? So this is negative 6 whole to the power of 0. So negative 6 whole to the power of 0 is, anything to the power of 0 is 1. Right? Now combo. So again, as you can see, as and when we are finishing things, we are looking at more difficult questions. So it will be combination of all the things what we have learned. So when you're learning something, learn it slow, understand everything, because we won't spend a lot of time on doing a lot of problems. See, we have to do a lot of problems just to understand something in depth. But if you spend enough time, you need not go to that extent of understanding in such a detail. Right? If you spend a lot of time trying to understand something, you can spend less time and understand a concept in detail. How do you do that? Just spend some quality time with a problem, pen, paper, sit with your pen, paper, book, no distractions, try to solve it and then watch the video. Don't do haphazard work. Don't sit with a problem and use your phone or get distracted, right? So whenever you do any problem over here, first thing is do it yourself. If not, it won't help. Okay. So what are we looking at? The base is of opposite sign. So you know what to do. We're looking at negative 12 and positive 12. So let me convert negative 12 to something which is convenient. So this is an odd number. So the negative will result in negative 1 into 12 to the power of 43. So now we are looking at the question 12 to the power of 51 divided by 12 to the power of 43. So this is nothing but 12 to the power of 51 divided by negative 1 into 12 to the power of 43. Right. A positive term being divided by negative term will result in a negative value. 12 to the power of 51 by 12 to the power of 43. So this is nothing but minus 1 into 12 to the power of 51 minus 43, which is nothing but negative 1 into 12 to the power of, what is the difference? 8, right? And that's your answer. Okay, the next question. Again, what we are looking at is basis, opposite sign, but it's of same magnitude. Now, how do you handle it? Well, I have to convert one of that to be same as the other. So how do you do that? Here we are looking at an odd number. So this will be negative 1 into 123 to the power of minus 41. The power won't change, it will remain the same. The next step is write the question 123 to the power of 5 divided by minus 1 into 123 negative 41. Okay, so we have positive divided by negative, which is negative 1 into 123 to the power of 5 minus of minus 41. Is it not? If you want to do one extra step, you can do it negative 1, because positive divided by negative is negative, and just copy the remaining part. Of course, it's of no use. This step won't make sense. It does make sense mathematically, but you need not waste time writing all of those. I would like you guys to jump on to the things which is helpful, more helpful. So negative 1 into 1, 2, 3. So this is negative of negative is positive, 46. Okay. Few more problems. So here we're looking at multiplication and division combination. So we have both multiplication and division. Try it out, it's not too hard. So do part by part. I told you, maths can be handled part by part. Okay, so think individually. Okay, we have division, or you have multiplication. So what do you do? Think part by part and resubstitute. So you will be done. Okay, so I hope you guys tried. So now we have a numerator and denominator. So I can handle numerator separately, because this is all multiplication and division. I can do whatever is convenient to me. So this is nothing but same base. So we have a to the power of 10 plus 3. This is nothing but a to the power of 13. Now we have a to the power of 10 into a to the power of 3 divided by a to the power of 6. So I need to substitute it over here. A to the power of 13 by a to the power of 6. So this is nothing but a to the power of 13 minus 6, same base, division. So I need to take the difference, that's all. So this is a to the power of 7, right? Again, easy set of questions. So over here we have again multiplication and division. So I'll start with the top part, 6 to the power of 10 into 6 to the power of minus 10. So this will be 6 to the power of 10 plus of minus 10, 6 to the power of 0. So let me not write it as 1. So I'm going to substitute in the numerator. We have this expression. The result of that is 6 to the power of 0 divided by 6 to the power of minus 4. So 6 to the power of 0. So normal division, same base. So what can you do? Negative of negative 4, which is nothing but 6 to the power of negative is positive, 6 to the power of 4. Is it not? So quite simple. I think these are the last two questions. So we can handle it part by part. So I'll take the denominator first, a to the power of 6 into a to the power of negative a whole to the power of 4. So we got a negative over here, while other one is positive. So the case is base is of opposite sign. Again, handle it separately, everything else will be okay. So negative a to the power of 4 is nothing but positive a to the power of 4, is it not? So you can write it separately, or you know already, so you need not keep writing all of this. You can directly write e to the power of 6 into positive e to the power of 4, and this is a to the power of 6 plus 4, which is nothing but a to the power of 10. So let us substitute it back into our question. We have the question to be e to the power of 10 divided by e to the power of 6 into e to the power of negative a to the power of 4. So this is nothing but a to the power of 10. In place of the denominator, I am going to write a to the power of 10 itself. So it's the same set of numbers, so I can cancel directly and write as 1. But I'll show you the exponential way. Since it's division, so the powers are getting subtracted as the base is same. This is nothing but a to the power of 0, and anything to the power of 0 is 1. Next we are looking at both numerator and denominator, right? So it has to be individually handled. So let's handle the numerator first. 3b whole to the power of 6 into 3b whole to the power of 4. The base is same and it is just multiplication. So we have 3b whole to the power of 6 plus 4, which is nothing but 3b whole to the power of 10. Next we have negative 3b whole to the power of 10 into negative 3b whole to the power of 7. Same base, is it not? Yeah, I mean the question, within this entire question, the bases are different. But if I take this as a question, the base is same. So I can solve it individually, no issues. Negative 3b 10 plus 7 negative 3b 17. Now all I have to do is substitute 3b whole to the power of 6 into 3b whole to the power of 4, entire thing divided by negative 3b whole to the power of 10 into negative 3b whole to the power of 7. So the numerator, write it separately, not separately in the numerator. Denominator has to be written in the denominator. Now we are looking at same magnitude base but different sign. So how do you handle it? First thing is negative 3b whole to the power of 17 has to be solved. So we know that this is 17 is an odd number. So this is negative 1 into 3b whole to the power of 17. Now let's substitute it. 3b whole to the power of 10 divided by negative 1 into 3b whole to the power of 17. So I have space actually. We have positive divided by negative is negative 1 into, if you want you can just write the remaining part, or you could have solved it directly. So this would have been negative 1 into 3b whole to the power of 10 minus 17. So this is negative 1 into 3b, 10 minus 17 is minus 7, and that's your answer.